Today, I'd like to walk you through the evolution of some of our quantum-related products and tell you a little bit about what we've been doing over the past 25 years for quantum. First of all, Toptica was founded in 1998, and we actually came as a spinoff of the Quantum Optics Group. Since that time, we've been constantly growing and meeting the applications in quantum with our laser systems. We've actually expanded to locations across the planet, including what you see here, which is our North American headquarters in Rochester, New York. Worldwide, Toptica is a team of about 380 employees now and growing rapidly, many of which have been directly connected to quantum their entire career. So we actually take pride in offering the broadest wavelength coverage of any laser company on the planet. And as you can see here, that includes our people too. Toptica started enabling quantum in 1998, as I stated before. And as we go through this presentation today, pay attention to the skyline of wavelengths to the right of the screen. It all began with the DL100 external cavity diode laser. This laser was designed with cold atoms and ultra cold quantum gases in mind. I'd actually bet the majority of the old school AMO physicists have come across this laser at some point in their career. As we continued to evolve and as the science continued to evolve, we actually drove into what's the DL Pro. The DL Pro is a unique cavity design that drove a high need for digital electronics as well and gave us the line widths and the capability and the stability that was now required for making quantum even more of a success. As the need fell into having the demand for more industrialized and a broader wavelength range, we introduced the DFB Pro. That gave us tunability and stability of what would become a semi-industrialized package. As we moved past into needing more power, and when those high power ECDLs were needed for things like optical lattices, we actually stepped up the power with our TA systems, the tapered amplifier systems that you see here. And we continued to evolve and been catching up with all of the new atomic species and new lines, for example, Rydberg transitions. And here we can do second and fourth harmonic generation lasers with the extended wavelength ranges that'll actually take it all the way down to just below 200 nanometers or 190 nanometers to be exact. Finally, we all know that quantum is not limited to just atoms. Condensed matter physicists have been pushing quantum boundaries with microresonators, photonic crystals, quantum dots, et cetera, pushing the boundaries in widely tunable lasers and exploring and utilizing the transition to those systems. So we developed mode hop free lasers with tunabilities of tens of nanometers in a most reliable fashion to make sure that we could give a robustness that's needed. Rounding out the wavelength range to get us up into the IRR, we actually pushed for the molecular species. And there we introduced a Prism award-winning OPO. The Topo, as we call it, is the most widely tunable OPO laser in the market. It's great for doing mid-IR molecular spectroscopy and ultra-cold molecular quantum chemistry. Still, keeping the high expectations related to narrow line width and adding tunability across the mid-IR range. We didn't stop with just the lasers. When it comes to making experiments a success, we pushed those innovations even further with our combs as well, and added the extension modules to give us a true system and really help continue to expand the application capability that was needed for the quantum marketplace. Finally, we get the need that compact lasers and integration becomes a key part of it. And we just talked about the need tied to making this table something that's actually usable. So we overcame this huge challenge with our T-Rack systems. These are fully integrated solutions for the most demanding quantum experiments. They're modular, we can customize them, and we can pull it all into a single package where we get the performance within the rack off of the table. In many cases, we can get them into a 19-inch rack mount systems without even needing that table environment. So we've engineered these systems in terms of noise cancellation, the passive cooling that's needed to make them work as good as our tabletop systems. And actually, the innovation doesn't stop. Breaking news this week, we're actually rolling out what we call the DL Pro FL and the TA Pro FL, featuring the highest quantum gate fidelities in ion-based quantum processors. So if you're building quantum computers, we're doing what we can to try to take the steps to make your build even easier, showing that, again, we are here for quantum because we are quantum. Toptica is here to continue the quantum evolution. Even if you don't see it in a product yet, you can rest assured that we're constantly scanning the quantum horizon to evolve the quantum universe. Whether it's PICs, industrialized packages, or the need for a system integrator, we're confident that Toptica can be ready when the quantum market demands the right solution. So to wrap up, Toptica has been developing high-end lasers for quantum applications for more than 20 years, and we see ourselves at the frontiers of quantum, from fundamental research to real-world applications and system integration. Toptica has enabled quantum industrialization with hundreds of product developments and the partnerships established over 2 decades. This way, we can leverage this unique experience and network to work with other quantum industries in different ways, from giving strategic advice to help mature their technology, collaboration and system integration, and even testing to make sure that we can bring quantum to a commercial state. Thanks for the chat today. If you've got any questions or want to talk to us more about Toptica or quantum, reach out to us. You've got our contact information here.
So Toptica has done a fantastic job supplying quantum researchers all the wavelengths and associated solution capabilities around those laser sources so that they can do their quantum experiments. And I think the big question for me and many of us is so when we start looking at beyond the research market, is if and what is Toptica doing? I realize maybe some of that might be sensitive, but where are you going in terms of like supporting outside of the lab? A little bit more than what you said in the presentation. Are you moving to things that are now going into development? Are you moving to things that are actually going to get deployed? What would you say to that?
We actually see both, Mark. If you take a look at the activity that we participated in, if you just look at something with the evolution of the T-Rack system, there you're going more vertically integrated to take more of the components that traditionally we might not have gotten involved with, whether it's the EOMs, the AOMs, and pulling those into a solution to get them more ready. At the other end of the spectrum, we also focus in on the integration piece. So if you look at programs like OptiClock, IQ Clock, and the flagship programs, we've actually been the system integrator in many cases on those high-end systems where we actually pull together competitors, other government entities, universities to provide an end solution. So what we're trying to do, our strategy has been to make sure that we are as useful to the quantum community as we can be from a commercial standpoint.
That's great. That's great. Have you ever partnered with other laser companies?
We have. Yeah, there's been a number of applications where we've partnered with companies like MPV and others. We're always looking for new application development to help further semiconductor development and so on. So short answer is yes.
What is sort of the remaining challenges in cost and size and new wavelengths? What do you see as remaining risks?
It's the answers that we're waiting from you, Mark. It's the market.
I'm glad I'm the market maker. Okay, thank you very much.
Just kidding. It really is driven by that, though, because so many of these things are, they're less of a physics problem and more of an engineering and market problem right now. So you saw that in Scott's talk, too. I'm getting something into an industrialized package. Sorry, I've got one in my hand, too. It's not the hard part. It's really getting the market that drives it. John mentioned there's over 100 wavelength choices. So the consolidation of getting that down so that we get something that has a useful market space to allow us to do the investment that makes sense for it.
I mean, you're speaking to the converted. I mean, it's a 100% economics problem. You know, for all the laser companies. I used to build and sell lasers too. I know it too well. Great, thank you so much.